Welcome to the Team Carbon for Climate X Prize carbon dioxide removal demonstration based at Titan Clean Energy Projects, located on Treaty 4 land in Craik, Saskatchewan, Canada. Team Carbon for Climate comprises Titan, Flowcarbon, the University of Saskatchewan, and Ttanka Oyate Holdings. The team will demonstrate Titan's proprietary and modular technology that converts biomass waste into a stable form of carbon, often called biochar or biocarbon. 1 ton of stabilized biocarbon removes approximately 3 tons of carbon dioxide from the atmosphere. The technology uses diverse waste materials including urban waste wood, such as rail ties and construction wood, and non-food agricultural waste, including flax and hemp straw and oat hulls. According to the U.S. Environmental Protection Agency, there is over 1 billion tons of waste biomass per year that is needlessly disposed of or goes unused in North America alone. But where will all the carbon go that is generated from this vast amount of raw material? Fortunately, carbon is used around the world in applications such as water and air purification, animal health, soil health, electric vehicle batteries, supercapacitors, and concrete and steel strengthening. By placing biocarbon instead of fossil carbon into these vast markets and ensuring that the carbon is not burned in the future, a cost-effective and circular solution to climate change is achieved. So how does it work? The first step is to receive the biomass, record the net weight of the waste material, and to document the origin of each truck that enters the Titan yard. Next, the biomass is unloaded, processed, and transferred into large walking floor semi-trailers that dock with a pyrolysis in-feed system. The autothermal pyrolysis unit runs 24/7 year-round and is controlled to maintain the biocarbon production temperature of 650 degrees Celsius, using the synthesis gas formed by heating the waste biomass in an oxygen-free environment. This reaction provides fully stabilized carbon, bio-oil, and wood vinegar. The biocarbon is then pelletized. Titan's process uses bio-oil and wood vinegar in its patented pelletization process for additional carbon entrainment. Pelletization provides densification and thus effective distribution of the final product. The final process is to heat the pellets at over 850 degrees Celsius to further stabilize the carbon and activate the carbon, giving it more desirable properties for its end use in water purification and sustainable agriculture. The pellets are weighed into 500 kilogram super sacks and sent to market. A critical task is to validate and verify the exact net amount of carbon removed from the atmosphere. Fortunately, this is very easy as the demonstration provides full digital monitoring, reporting, and verification. Almost all of the energy used in the process is derived from waste biomass, and the process sequesters the majority of the carbon entrained in the waste materials. Team Carbon for Climate will demonstrate that the carbon can be sustainably stabilized and removed from the atmosphere in a cost-effective manner at the kiloton removal scale. Waste biomass is needlessly burned around the world, especially in the developing and tropical worlds. Team Carbon for Climate will validate the numerous circular and social benefits of the process that include waste reduction, carbon sequestration, and the beneficial use of carbon for cleaner air and water and sustainable agriculture and food security. The demonstration will illustrate the cost and the opportunity to use voluntary carbon finance mechanisms to responsibly deploy 88 modular processing units to reach 1 million tons of carbon removals per year. This will forge the pathway to the needed gigaton carbon removals through this modern carbon sequestration technology. Biochar had its roots in agriculture more than 4,000 years ago in ancient Africa and Amazonia. Today, using Titan's advanced manufacturing technology, it provides a critical opportunity to remove carbon from the atmosphere in the fight against climate change and for climate adaptation.